Hello everyone, and welcome back to the Frame channel. With its lightweight, high tensile strength and an infinite recyclability, steel is a truly versatile and effective material. With a wide range of applications across transport, construction, and fuel infrastructure, it is difficult to imagine a world without steel's presence. But how does this super strong titan of industry begin its journey? And how do steel mills produce the wide range of products available to end users today? In this video, we'll explore the hypnotic industrial process of bending massive steel plates. Steel is manufactured from a combination of iron ore, limestone, and coke, which are heated to more than 2,000 degrees Celsius in a blast furnace to form molten iron. Transforming this molten metal into steel requires a further step, namely adding carbon to improve its strength. This process involves adding liquid iron to a basic oxygen furnace, or BOF, that contains a smaller portion of recycled scrap metal. Oxygen is then blasted through the furnace to remove any excess carbon from the newly formed malleable alloy. Once manufactured, the metal needs to be shaped. Hot steel created in the furnace is rolled to achieve general measurements required for further processing. It is then allowed to cool to room temperature before undergoing a process known as cold rolling. Cold rolling, which allows for greater control over the dimensions of the product, helps steel producers achieve high-quality, precise results. Cold-rolled steel products also have smoother, more aesthetically pleasing surfaces than those that have undergone hot rolling only. Once it has been rolled, shaped, and cooled, the steel can then be cut to form large plates before further processing is used to create the desired profiles of the finished products. Often, this means that the steel must be bent into position. As you can imagine, bending such a strong metal requires a great deal of force, and units known as press brakes are perfect for these applications. The top half of a press brake, known as the punch, pushes down forcefully towards the machine's lower half, which is called the die. As the steel plate becomes sandwiched between the machine's two halves, the force of the punch causes the metal sheet to bend to fit the shape of the die. Due to the vast range of applications for which steel is used, the thickness, length, and shape of these products vary greatly. Steel rolling mills, therefore, must house an array of machines that perform various molding, shaping, and bending functions to create specific shapes. For example, angle rollers are used to transform steel tubes into spirals, and different configurations of plate rollers, such as a 4-roll plate roll, can be employed to create shapes such as the cone-like product seen here. Frontline companies in the steel industry, like US Steel, keep pushing the boundaries of innovative steel bending processes with new and advanced manufacturing technologies.
During the past year, US Steel has announced a series of investments in leading technology and advanced manufacturing. This has included XG3 at ProTech, our third-generation advanced high-strength steel for automotive solutions. The endless casting and rolling facility investment at Mon Valley Works. Significant upgrades at our Gary Works hot strip mill. The Dynamo line at U.S. Steel Košice.
Computer numerical control, or CNC, allows for further precision during steel fabrication. These machines are able to repeat tasks such as drilling or punching holes by using exact and accurate measurements time after time. This method enables companies to produce reliable and uniform components used in construction and other industries on a massive scale. CNC machines can also be used to cut steel accurately, again creating end products that consistently meet exact specifications.
It is a CNC machine which is operated by one person. It's mostly automated. All the files are produced by our in-house design engineers, which reside upstairs over there. Then the operator imports the files into the computer behind me and basically puts the play button, and the machine produces all these plates.
When manufacturing steel strips, which require lower levels of precision, hot rolling, a process we came across earlier, is often the best option. At the mill, slabs of cooled steel are heated to approximately 1200 degrees Celsius before being reshaped. Horizontal rollers achieve the desired thickness of each strip, while vertical rollers are used to create their required widths. Once the finished steel strips have been rolled into coils and cooled, they can then be stored or shipped to factories where they undergo further processing to create many of the familiar steel products we use in our daily lives. Though their basic composition may be the same, the products from the cold-rolled and hot-rolled processes have their differences. From cars and buildings to bridges and railways, and even, quite literally, the kitchen sink. The sheer number of products that depend on steel production would suggest that customer demand is unlikely to wane anytime soon. The global steel market was valued at $109.2 billion in 2020 and is projected to exhibit a compound annual growth rate of almost 4% during the 10-year period between 2021 and 2031. The replacement of structurally deficient infrastructure and the reconstruction of bridges, especially in third-world countries, are some of the factors predicted to drive this growth. The ubiquitous nature of steel, coupled with its recyclability and relatively low carbon footprint, means that its future in the global marketplace appears all but guaranteed. We hope you enjoyed this feature from the Frame channel. If you want to see more of this type of content, please hit that like button and subscribe. See you soon!